When a production line halts for maintenance, the facility enters a period where every hour of downtime represents thousands of dollars in lost revenue. Standard cleaning contracts focus on routine janitorial tasks, but these schedules cannot accommodate the specialized decontamination required for heavy machinery. Turnaround cleaning involves hazardous residues and unstable chemical environments that demand a different level of technical oversight. Misidentifying the complexity of these environments leads to delayed restarts, flash fires inside vessels, and the spoilage of multi-million-dollar product batches if bacterial colonies remain in the lines. Shutdown decontamination is a process defined by chemical neutralization, fluid dynamics, and atmospheric math. Two specific hazards often escape routine inspection: stagnant fluid trapped in dead leg pipelines and flammable vapors lingering in process vessels. Mitigating these risks requires a three-phase sequence: preparation, deep cleaning, and commissioning, executed while the plant is offline. This sequence ensures the facility adheres to regulatory frameworks like AS 2865 for confined spaces and international COMA standards for major accident hazards. This technical cleaning dictates the entire maintenance schedule. Without a certified clean environment, the maintenance crew cannot work and the facility cannot restart. Phase 1 begins before production actually stops. While the plant is still active, specialist crews arrive to map hazards and establish cleaning zones. Hazard mapping identifies risk zones using facility drawings. The team determines which vessels require chemical neutralization and which pipelines carry pharmaceutical-grade product, setting the technical requirements for the extraction. All energy sources are physically isolated through a lockout-tagout system. Red tags are placed on specific valves to cut off water and electricity, ensuring no equipment can accidentally start during the clean. This isolation is documented in a Safe Work Method Statement and a Permit to Work system. These documents link every physical valve and hazard to a specific safety procedure and authorized personnel. Under the WHS Act 2011, this documentation serves as the legal record of safety compliance. It provides the evidence required if SafeWork NSW audits the facility during the shutdown. The Permit to Work system specifies the exact chemical handling protocols and atmospheric limits required before a technician can begin work on the equipment. Phase 1 establishes the documentation and physical isolations needed to manage the plant's risks before the first pipe is opened. In Phase 2, production has stopped and vessels are empty. This is the core decontamination period, where the deepest hazards are addressed. The most critical hazard in Australian industrial pipelines is the dead leg. A dead leg is a section of pipe that branches off a main line but ends blindly. Because there is no return loop, the process fluid bypasses the branch, leaving a zone of stagnant liquid. In food processing, bacterial colonies grow inside these stagnation zones. These contaminants survive standard cleaning flushes and can migrate back into the main line during production. In chemical processing, stagnant fluids lead to internal corrosion. This weakens the pipe walls from the inside, creating the risk of a high-pressure failure once the plant restarts. Routine high-volume flushing often fails here. The velocity of the flush in the main line creates a bypass effect that leaves the debris in the dead leg completely untouched. To fix this, teams follow the UK HSE COMA protocol. Every dead leg is mapped using the facility's architectural drawings to ensure none are missed during the decontamination. Technicians flush each dead leg individually, working from downstream to upstream. This sequence prevents contaminated fluid from being pushed back into sections that have already been cleaned. Success is verified through discharge monitoring. The team tracks precise flow rates, inspects the discharge color for particulates, and conducts swab tests for safety. If even one dead leg is ignored, the entire mainline flush is compromised. Removing these hidden stagnation zones is a requirement for a clean facility restart. While pipelines are being flushed, larger vessels like reactors and mixing tanks are classified as confined spaces under the AS 2865 standard. Maintenance often requires hot work, welding or grinding inside these tanks. If the vessel contains even trace amounts of flammable vapor, a single spark can cause an explosion. Before any maintenance can begin, the cleaning crew must decontaminate the surfaces and certify the atmosphere as gas-free. Safe entry is determined by atmospheric testing. Oxygen must measure between 19.5 and 23.5%, while toxic gases like hydrogen sulfide and carbon monoxide must be below 10 and 30 parts per million, respectively. For hot work, the lower explosive limit must be verified. The concentration of flammable vapors must be documented as below 10% of the level required for ignition. If these levels are not met, the crew implements forced ventilation or chemical scrubbing to bind the contaminants. The space is retested every 30 minutes until the readings remain stable. The AS2865 standard also mandates that no technician enters these spaces alone. A rescue coordinator stays outside the entrance to monitor the entrant and manage a certified retrieval system, ready for immediate extraction if the atmosphere shifts. A gas-free certificate is a technical verification that the environment is safe for heat-producing tools, ensuring the maintenance team can work without the risk of an atmospheric ignition. Phase 3 is the commissioning clean. This happens after the maintenance teams have reassembled the machinery, but before production restarts. The final step involves a complete tool accounting check and a final atmospheric clearance. Every piece of cleaning equipment and maintenance tool must be verified against the site manifest. This accounting prevents foreign objects, such as rags or wrenches, from being left inside the process lines, where they could cause catastrophic damage during restart. A joint handover inspection is conducted with the facility's operations and maintenance teams to review all cleaning logs and certificates. This inspection identifies any maintenance oversights, such as loose fittings, that could lead to environmental violations or product contamination. Completing the Phase 3 handover transfers the operational responsibility back to the facility manager, supported by a full compliance file. The speed of the maintenance crew is dependent on the technical rigor of the cleaning phase. If decontamination is incomplete, the entire schedule slips. Because of the high cost of downtime, facility managers use specific contract structures to manage their financial and operational risks. Fixed-price contracts work best for planned turnarounds, where the scope and residues are known in advance. This provides a set budget for the operation. Day-rate contracts are used for emergency shutdowns. They provide the flexibility to scale the crew and equipment rapidly when the extent of the contamination is unknown. Time and materials is the standard for most large Australian shutdowns. It allows the cleaning scope to adapt if the maintenance teams discover additional corrosion or deposits during the deep clean. Specialized shutdown cleaning removes accumulated residues to reset the facility's safety and compliance levels. Following these strict engineering protocols ensures the facility meets regulatory standards and achieves a safe, profitable production restart.